Hello, myself Mr. Amit Kusnale. Here I am going to give an introduction of consistent deformation method. Of course, this method is used for the analysis of indeterminate type of structure. To analyze completely an indeterminate structure, along with the equilibrium equation, we have to use compatibility conditions. Of course, the compatibility conditions we can write by consideration of the joints. I will explain later the compatible conditions. In this example, reactive forces are taken as unknown, hence this method is a type of a force method. Now come to the compatibility conditions. So as per the syllabus, only there are two types of the structures are there, that is propped cantilever and fixed beam. So now I will consider compatibility conditions. So to consider compatibility condition means just we have to consider the properties of a support. So of course here A is a fixed support, that's why rotation must be equal to 0, that is theta A must be equal to 0. Of course at A and B there are the supports, that's why deflection at the support must be also equal to 0. Same way in the second example, that is in fixed beam, as A and B are the fixed support, theta, that is rotation, must be equal to 0. And there of course delta A and delta B is also 0 because at A and at B there is a support. So these are the compatibility conditions which we will use while analyzing a structure by consistent deformation method. Consistent deformation method can be used by considering moment area method, Macaulay's double integration method, conjugate beam method, strain energy method. Out of all these methods, of course the moment area method is simple one, that's why here I am going to solve all the examples by using moment area method. To solve example by moment area method, just we are required this table. So just I have shown here three diagrams. First one, just there is a cantilever beam subjected to point load, cantilever beam subjected to UDL and subjected to UVL. For this we are getting this moment diagram. These are three moment diagrams. Here I got a straight line, here there is a parabolic curve, here there is a cubic curve. So I shown here degrees. This is a first degree line, that is straight line, second degree line, that is some curve, third degree line, more curve we are getting, that is cubic curve. This is the formula for the area. These are the central distances. Just you can keep in mind this table. Likewise here there is half of base into height, so 1 by 2 here, so next value is 3, next value is 4. Likewise you can keep in mind, and of course just this value, if you remember this value, of course second value you can find. Here we are taken 1 by 2, next of 2 is 3, so we are written 3, next of 3 is 4, next of 4 is 5. So likewise you can keep in mind. After this directly we go to the problems. These are the steps which we are required to follow to solve the example by using consistent deformation method. Of course the first step is to find the HDI of the structure. As we are going to find HDI of the structure, that's why it is called as a type of force method. Now next, just define unknown and just remove that unknown. By removing that unknown, we are making the structure a determinate structure. After that, on that determinate structure apply loading and next apply the unknown. Next use the compatibility condition and equilibrium equation. After that you can come to the drawing of SFD and BMD. Better we can understand this part at the time of solving the problems. This is the sign convention, that is displacement in the direction of unknown, take it as positive. Of course, this all you can get clear while solving the problem. Now let us come to the problem.